This is part 3.1 of optimization problems. I know that I said I'd do it in three parts, but it'd just be too long because I've still got another 39 slides to go. And in parts 1 and 2, they were around 12, 13 slides each, and those videos were around 20 minutes. So it'll just be too long. And I think you guys would be more inclined to watch the video if it was a bit shorter, maybe around 20 minutes maybe. Anyways, so this is part 3.1. I'm doing all of the questions from this part, and it starts with how many stars there are here. So 4 stars and then a plus. So starting from then onwards are all the questions that I'm going to be doing. This is the first one. So you've got like this baking tray and you've got these dimensions. So this is a trapezium. These two are both like identical. You've got a rectangle here and a rectangle here. These are both identical. And you've got the length here y, the height x, and then this bottom length 10x, and this is 12x. And the capacity, in other words the volume, is 1980. So to find the volume of a shape like this, well, what you can do is you can imagine it as a full rectangle, and then take away. If you imagine these triangles here, so if I draw these lines on here, you can imagine this like this shape here, and then the other one on the same side, on the other side, sorry. And if you do the full rectangle's volume, take away this and that, you'll get the volume of the shape, and then you can make that equal to 1980. So if we say that this is x, this here would be y, because it's the same as that one. Okay, and then the volume would be 12x multiplied by x, so it'd be 12x multiplied by x, that's the height. Okay, and then it'd be taken away 1/2 x multiplied by x, y. So, and then that's just one side. Okay, and then you multiply that by 2, so you do 12x multiplied by x, take away 2 lots of 1/2 x squared y. You get that. You can just add it up. Obviously the 2 and the half cancel. This becomes a 12x squared, and then this becomes a minus x squared y. And you can make that equal to 1980. If you look down here, we want everything in terms of x's, so if you see a y here, you can just rearrange for it, and that's what I'll do. So yes, so literally just do that. Rearrange it like this, divide by x squared, and you'll get, what have I done? Minus x squared, so bring that side, bring that to the other side. Okay, yeah, obviously, yeah. Okay, so you get this, okay, and then divide by 11, x, and you'll get xy. Okay, well, no, yeah. Yeah, so I've put it here as xy, I've rearranged for xy. I'll show you later why. You can just leave it as rearranging for y, but it'd be easier to do it this way. You'd get the same answer either way, and I'll just show you why this is a bit better. So just repeated that for no reason. So if we look here, we've got x here and we've got x here. Okay, so we have x squared. X squared add x squared equals whatever this length is squared. And the reason why we want this is because we want the surface area. So we want this rectangle, this rectangle, this rectangle, and then these two trapeziums. So if we get the hypotenuse here, it'd just be root 2x for here. And then you have this length here, which is y. So y multiplied by root 2x is the area of this rectangle here. And then we're going to multiply that by 2 to get it for this one here. Okay, and you've got, what else? So you've got this 10x y here. And then you've got a trapezium. So the formula for an area of a trapezium is a plus b divided by 2 times by height. So you've got here 12 add 10x, 12x add 10x, divide by 2, multiply by 10x the height. You'll get that as the area. Just add it up, so the 2 and 2 cancels. This becomes a 22x squared, and then this becomes a 2 root 2xy. And yeah, that's fine. Okay, we know what xy is, so we can plug that in here and here. Like I said, you could have just rearranged for y and then plugged in just for the y's, but it's just quicker to do it this way. So we're just going to plug that in there, and there. I don't know why I've repeated that. This is 1800 over x. This is 360 root 2 over x. These are both the same denominator, so just collect the like terms. Like that. If you look at this, we don't have a denominator where we've got the z, so we're just going to take out 1 over x. And if you look a bit more closely, we need to somehow get a 5 and then plus root 2. So we need to get rid of this 360. So we'll just factorize out 360. You'll get that. and then just obviously swap these two around to show that it's how the question wants it. Determine the value of x for which a is stationary, showing that this value of x minimizes the value for a. Okay, so we need to differentiate. Okay, this is just the area. I'm gonna rewrite it like this. This is obviously x to the minus 1. Okay, because it's and then we're just gonna differentiate this. The reason why we differentiate is if you imagine, like, if you look at this is parabola. Okay, and it's going up like this. Okay, and we want the minimum value, and obviously the minimum value is going to be at this turning point here. And obviously turning points are stationary points, and they occur when the first derivative is equal to 0. And then that value of x will minimize the area. So we're going to differentiate this to get 44x, and then plus, there will actually be minus 360, and then x to the minus 2. And that equals 0, like we just said. This is the same thing as saying, this part here is the same thing as saying this. Add it to both sides, multiply by x squared. I've divided by 44 and then cube root all of that to get x is 3.7. So this value of x minimizes the surface area. What else do we need to do? We need to show that it does minimize it. So if we find the second derivative, remember just x equals 3.7 for later. Second derivative is 44, and then it's plus 720, and then the slot x to the minus 3. Minus 2 multiplied by minus 360 is positive 720. You'll get this, and then you might be able to just see from here that this is definitely going to be positive, therefore it will minimize the area. So you can just plug in 3.7 just for the sake of showing it, and then you can just say, well, this is obviously positive, so it minimizes it. To find the minimum surface area, we just need to plug in this value into the surface area equation that we have, and you'll get this, and that's the answer. Okay, so we've got this shape here, and we've got these dimensions, so you can just read through this if you want, it doesn't really matter. The volume is 2,880, so we'll get the volume. We've got pi r squared h, and then the volume of a sphere is 4/3 pi r cubed. So half a hemisphere, half a sphere, will just be half of that. So that's half 4/3 pi r cubed. This becomes 2/3 pi r cubed. You get this, that equals 2880 pi. We're going to rearrange for h because here it's only in terms of r, so not in terms of h. We'll do that, you'll get this. I'm sure you can rearrange for this. You just take away 2/3 pi r cubed and then divide by pi r squared. You get this, and then we want the surface area. So the surface area is going to be 2 pi r multiplied by h, and that just gives us it's this part around the outside basically. And then we've got the surface area of the sphere. What have I done here since then? Nothing. Oh yeah, I've just cancelled the pi's. Okay, and then we've got 4 pi r squared for the area of a sphere, but we want half of that because it's a hemisphere. To get that, and then obviously this pi r squared at the bottom, and this 2 pi r h is what was on the outside, remember? Just collect like terms, you'll get this, and we've got what h is, so we'll just plug in h into there. The r and r squared cancels. You'll also get nothing else cancelling. Okay, so it's just that. Distribute the 2 pi to get this, and let's see what we can do. Okay, well, if we increase this by r, so we have 3 pi r cubed over r, then we can just put these together. And then what can we do? So we can factor out a 1 over r. First of all, let's collect them, then factor out 1 over r. Oh no, I've not done that. Okay, so I've just collected the top together. Anyways, we are still going to factor out 1 over r, and then we'll collect, and then we'll can also factor out a 3 from here, and then we'll collect a 5 from the top. So 5/3, collect an r, and a pi as well. You get that, and that's exactly how you want it. You can just swap these two around. I don't think it really matters. Show further that when s is minimum, r equals h. Okay, so when s equals minimum, there's obviously going to be a stationary point. This here it's the same as saying this here, all multiplied by a third, and then r to the minus 1. Okay, distribute the third r to the minus 1. So this is 17,280 pi divided by 3 multiplied by r to the minus 1. And then this is just 5/3 pi r squared. Because, you know, when you multiply the r's, you just add the powers, but because this is a negative, you subtract. You get this. We're going to differentiate this. So this becomes this. So it's minus 5,760. Decrease this by 1. Minus 1 minus 1 is minus 2. 2 multiplied by 5/3 is 10/3 pi r. Reduce this by 1. Get that. Make that equal to 0. And then add 5,760 pi r to the minus 2 on both sides. Is that what I've done? Yes, it is. Okay. Multiply by 3 and then multiply by r squared. You'll get this. Divide by 10 to get this. And if you just cube root both sides, you get r equals 12. Show that this actually is a minimum. Okay, we're going to get the second derivative, and then we're going to need to show that this is greater than 0. So this, we're saying that this value of r minimizes this, what is it? The area. Okay, so you plug in 12 into there. This is greater than 0. You can kind of just say, I mean, you've got all positives and you're adding them together. So it's definitely going to be greater than 0. And then to show that r equals h here, if you remember, this is just the volume, the original volume that we came up with. We know what r is, so we'll just plug it into there. And then we're just going to rearrange very slowly for h to get h equals 12. So obviously r equals h. The profit of a small business is modeled by this equation, where x and y are positive variables. Okay, that's going to be important for later. And it's also constrained by this. So what we need to do is, we'll rearrange for y here to get a y equals 54 minus 3x. And we'll just shove that into there, wherever we see a y. You'll do that. You might want to use a calculator just to save time. You can just collect minus 18 minus 54 collects 324 minus 324, they cancel. And 3x squared is just by itself. You can divide by 3 here, as long as you're careful with only dividing by 3 with one of the binomials. If you might not be able to see that and you accidentally just mess up here, it might be easier to just show these as 2 separate brackets and then divide by 3 with just one of them. Or divide by 3x actually, because they've all got x's in them. You'll get this, expand this to get that, collect like terms, this is minus 36x squared. You'll get that, and that's how the question wants it. Show that the stationary value of p produces a maximum value of 96. Okay, so p is this, okay? And then we're just going to differentiate that. So 108 minus 72x plus 9x squared equals 0. I divide by 9 to get this, and this is x minus 6, x minus 2. So either x equals 6 or x equals 2. Now to find which one maximizes the value for p, we'll just try them both, okay? So we've got p here, and then this is the second derivative. We've just gone from here to here. And then we'll just find which one gives us a negative value. If you plug in 2 here, you'll get this. So minus 72 plus 36 is obviously going to be a negative, so this is a maximum. Now if you try 6, you get minus 72 plus whatever this is, and this is definitely greater than 0, so this is the minimum. We want the maximum, so we'll take 2. Okay, so we'll just cross out 6, we don't need that. And then plug that back into p here to get what the maximum value is, so we've got 96. Here we're saying that the profits are actually much higher, and show why they are. Okay, and the reason why that is, so if we imagine this here, we know that x equals 2, so we'll just plug that into there to get 6 plus y equals 54, so meaning y equals 48. We know that both x and y are positive variables. Okay, and this is p, I don't know why I prepared it, but x and y are both greater than 0. Y equals 54 minus 3x. I've just rearranged this. And we know that this here is going to be greater than 0, so we'll just say that. Okay, add 3x to both sides, divide by 3. So it's between 18 and 0. It's obviously going to be between 0 because x is positive. So, x can actually be much higher. If you plug this in, you'll get really high profits with x. So this is why it can be much higher. You can just try it in you get 7,776, which is much higher than the 96 which we predicted. And that's everything for this part. Thanks for watching.